Okay, so these are the questions I said to focus on for your quiz. And I also said from section 4.1, numbers 15 to 44. I won't post solutions to that, but that was what our classwork and homework problems that I told you to focus on. That's all on the indefinite integral practice. Okay, so the directions for numbers 81 and 83? No, 81. Consider a particle moving along the x-axis, where x of t is the position, x prime is the velocity, and x double prime is the acceleration. So here's the function. Find the velocity and acceleration of the particle. So you guys are good at that. First derivative is the velocity function. 3t squared minus 12t plus 9. And we know that derivative of velocity is acceleration, 6t minus 12. Find the open t intervals on which the particle is moving to the right. Rest assured, this is not on your quiz tomorrow. I know it was on your Chapter 3 test, but a function is moving to the right when its position is increasing. When does a function increase? When its rate of change is positive. So we're looking for the intervals where the velocity is positive. So our velocity function was 3t squared minus 12t plus 9. Factoring out a 3 and setting this equal to 0. This factors to t minus 3, t minus 1. So the velocity is equal to 0 at 3 and 1. Okay, you're given the interval from 0 to 5, so that's going to bound our number line. So 1/2, 2, and 4. Plugging 1/2 into the velocity function, negative times a negative would give us a positive interval. 2, negative times a positive is a negative, and then 4 would give us positive. So to answer the question, the particle moves to the right on the intervals from 0 to 1 and 3 to 5. And why is that? Because the velocity is positive on those intervals. Find the velocity of the particle when the acceleration is equal to 0. So we found our acceleration function to be 6t minus 12. Setting that function equal to 0 and solving for t, we get 2. Find the velocity of the particle at 2. Our velocity function, I'm going to use the factored form, gives us a velocity of negative 3. 83, a particle moves along the x-axis at the given velocity. At time 1, its position is 4. Find the acceleration and position functions. All right, let's start with velocity. So writing that as a power rule, t to the negative 1/2 power. The acceleration is just the first derivative of velocity, negative 1/2, t to the negative 3/2. So negative 1 over 2t to the 3/2. Okay, where does the position function come from? The position function is the antiderivative of the velocity function. So the antiderivative using the power rule. Add 1 to the exponent and divide by the new exponent. Dividing by 1/2 is multiplying by 2 over 1. And then plus c. Every indefinite integral needs the plus c. Now we use the initial condition. We're told at time 1 the position is 4. So 4 equals 2 times the square root of 1 plus c. So c is equal to 2. Now putting it all together, what's the position function? 2 root t plus 2. Again, the antiderivative of velocity is the position function. So this is the general solution for the position function. Then you take the given information to find the particular solution. And what separates the general from the particular? We're able to find the value of c. 84. A particle initially at rest moves along the x-axis such that its acceleration is given by the function cosine of t. At time 0, its position is x is equal to 3. Find the velocity and position functions. Okay, so the integral of acceleration, so the integral of cosine of t dt is positive sine of t plus c, and that's the general solution for the velocity function. Now this was a little bit challenging. The particle is initially at rest, so that means the initial velocity is 0. So sine of 0 plus c is equal to 0. Sine of 0 is 0, therefore c is equal to 0. So the velocity function is just sine of t. So now the integral of the velocity function the integral of the sine function is negative cosine of t, because what's the derivative of negative cosine? Positive sine. This is the general solution for the position function. So at time 0, the position of the particle is 3, so using that condition, to solve for c, negative cosine of 0 plus c equals 3, negative 1 plus c equals 3, c is equal to 4. So to put it all together, the position function is negative cosine of t plus 4. So part B to that question, find the values of t for which the particle is at rest. Particle is at rest when the velocity is equal to 0. So we found the velocity function to be sine. So where is the sine equal to 0? At any interval of pi. So at n pi. And n would be a positive integer, because we're told time is greater than 0. Alright, now section 4.2. Consider the function 3x plus 2. Use 6 rectangles to find the upper and lower sum approximations of the area bounded between x is equal to 0 and x is equal to 3. So delta x, b minus a over 6. So the width of each interval is going to be a half. Alright, the boundaries from the definition, they're the vertical lines, x is equal to a, x is equal to b. 3x plus 2, it's an increasing line, so the left endpoints are going to be our lower sum. Alright, area of a rectangle. The width of each interval is equal. Where does the left sum start? At the value of a, and then we add the intervals according to delta x. F2 plus f of 5 halves. Stopping at one interval less than b, because if we added a half again, we would get to f of 3, and the left endpoint can't end at the right endpoint, the left endpoint sum. So where do the function values come from? Plugging back into the original. So f of 0 gives me 2, f of a half, 3 halves plus 2, 3 plus 2, 9 halves plus 2, 6 plus 2, and then 15 halves plus 2. I promise you, but the answer will come out to 17 1/4. You can verify the answer. Again, because the function is increasing, the right endpoint will represent the upper sum. Now for the quiz tomorrow, I would just need to see what the function values are. So the right endpoint starts at a plus delta x, and then we add intervals of a half until we get to the value of b. talked about this, but look at all of the overlap in the left and right upper sum, or left and right endpoint sums. The left endpoint starts at A and excludes B. The right endpoint excludes A and ends at B. So we would really just be subtracting 2 from this and adding 11. But again, you can verify the answer, and it would be 21.75. That doesn't seem to make sense. We'll come back to that if we have time. But upper sum, lower sum, that's what I would be looking for. Consider the quadratic function. Use 4 rectangles to find the upper and lower sum approximations of the area bounded between x equals 2 and x equals 4. And I asked you to set this up only. What does that mean? Don't find an answer. Alright, delta x, b minus a over n. So the width of the interval is, again, a half. X squared plus 4 plus x minus 4, that's going to be an upward facing parabola, and between 2 and 4 the function's increasing. So again, the left endpoint will represent the lower sum, and this is what I'm looking for on a setup. Delta x, and then give me the correct function values. G of 1/2, oh, sorry. Start at A for the left sum. G of 2, and then add intervals of a half. So plus G of 5/2, plus G of 3, plus G of 7/2. That would be the left and therefore the lower sum, because G of x is increasing. And the right endpoint would be the upper sum. So what's the setup? Now all the overlap and you end at the value of b. And that's all I want to see on a setup. I want to see you have delta x, you have the function values correct, and that's all you need.
Che, please come to the main office. Che, please come to the main office.
Okay. Please don't forget to focus on numbers 15 to 44 from section 4.1. Okay, that's your antiderivatives, and know your trig. All right, we always have to focus on trig. Know your trig antiderivatives. Have a nice night.